Hey guys, I'm just going to show you here my sample presentation I made for you guys. So I'm taking what you guys owe for me and I'm putting it into an example so you can follow along and kind of use this as a good model. So this video is in the directions, and I'll also post another video explaining the directions more in detail. This one is going to be more specific to the sample and for you to follow along. So I created a Google Slides. You can create whatever other method you want. I'll explain that in the other video, but let's start with this. So I want you to first just tell me a little bit about your given pandemic that you've been researching the past few weeks on. Okay. Um, I chose for the sample to do the most recent pandemic, the coronavirus that we're in right now. And I did this because I know none of you got this as a pandemic where you're all researching past ones. So there's no one at an advantage or a disadvantage because they can't really get this exact data. This is just again to help you model it. Okay, so tell me a little bit about it. I'm not too familiar with all the pandemics out there. So just a couple sentences, maybe a picture. Okay. Now let's get into what you owe for our math class, our Algebra 2. Okay, so directive one is to find two graphs. Okay, so I found one graph. Easiest way to do this is just Google graphs involving your pandemic and things should come up. What you're looking for when you Google this is a graph that has an X and a Y axis, okay? And everything needs to be numeric, meaning I don't want things that can't be numbered. So like this, we can number it because it's dates, okay? And the numbers are cases, that's a number. I saw an example here that looked at symptoms, and it was a graph. It was a nice looking graph, but I can't number a symptom, okay? For the math part of this, it needs to be something that you can number. And then you're going to look at this graph and you're going to answer a couple questions about it, okay? You're going to tell me, what is the x-axis? Well, those are dates. What are the y-axis? Those are the number of cases, okay? Then your domain and range. Remember, domain, left to right. So the furthest left value is March 1st. Furthest right value is March 28th. Okay, and I'm using brackets because those are included. You would use parentheses if you had like infinity as one of your values. Um, Range, bottom to top, okay? The lowest value is 0. The highest value is this 36,221. Then you want to look at max and min. Remember, max is your highest point. My highest point is March 28th, 36,221. Make sure you write it as a coordinate. My lowest value is March 1st, and it's 0. Okay, your x and your y. If it's hard to tell, you can always estimate it. Okay, sometimes these graphs are hard to tell. Just make an estimate. Then we look at increasing or decreasing. Remember, that's if you take your pen or your pencil, or your finger, or your mouse, and if you follow it along the graph, what's it kind of doing? Okay, this one's increasing the entire time. Looking at the yellow graph here. And when you do your interval, you're looking at your x values. So at the bottom, it's increasing from March 1st to March 28th. It is not decreasing at all. I know it looks a little constant right here, but I'm just going to assume it's increasing. And then part 5 of this is just 2 sentences explaining the graph. It's really good if you add some of that math vocab like I did. Just generalizing the graph in your own words of what it shows. So if I just saw the graph in this sentence, I'd be pretty familiar with what I just saw. Okay, then directive 1 says find another graph. Okay, so you're finding 2 graphs total. Try to find something different. It could be comparing the same thing, but I want my x and y values to be different. And notice up here, and I did it on the other one too, I put where I got this graph from, okay? So make sure you do sources and citations. This graph's different, has different dates, it's comparing different cities and different cases, okay? And then you're doing the same thing. X-axis, y-axis, domain, range. Notice this domain's different. It starts at March 11th and it goes to March 31st. The cases, the range starts at 0, goes only to 8,000, okay? So you might have to change a couple things. Again, I'm doing another statement summary, Okay, this graph is comparing the various states in the Midwest and the number of total cases of the virus. Indiana's rate is growing the fastest, following an exponential model. Okay, give me that nice summary sentence. If you need help with any of this, please reach out. This is, though, directive 1 still. I don't know why I wrote 2. Okay. Now we're on directive 2. So directive 1's probably, I think, the hardest and the most challenging part because you've got to find all the information. Like, you've got to find all this research. You got to find these graphs. Once you have the graphs, you are going to then use it to do the more mathy portion of it. So directive number 2 says take one of the graphs that you did. I chose the first one and I recopied it over here so I could look at it. And you're going to create a table from it. Okay. I know it might be really challenging to do this because you don't know exact amounts, but just guess. Okay. So I'm going to go to now just numbers in this table. Okay. I'm not going to include March. I'm just going to say 1, which means March 1st. And at 1, the value is 0, 4, 0, 7, 0, 10, 0, 13, 0, 16 goes up to about 500. I'm just guessing. 19 is at 4,500. 22 is at 12,500. 25 is at 21,000. 28 is at 36,221. Okay, so create that table and make sure you put this in your project. That's part 1. Now, part 2 of this directive is doing some work. Okay, I want to create an equation. Most of these graphs, at least in my example and probably in yours, are going to follow this exponential model. Okay, remember it's that like straight up or like that little swoosh. Okay. For exponential model, we've learned a process on how to solve for it. So what I'm going to do is I'm going to take 2 points from the table. Please don't choose any of the points that are 0. Okay, choose 2 different points, just because the 0 is going to kind of mess up a bunch of things, and I don't want that happening. So I chose my coordinate 16,500 and 28,36,221. It's always a good idea to choose the last coordinate because that's going to really help you with your prediction. And I put down the 2 coordinates, and this is the general exponential equation, y equals ab to the x. Okay, you've got to solve for a and b. We'll see in the note packets that we'll attach to this if you need extra help on how to do this again, okay? Or again, just ask. So I have my x and y, I'm going to plug it in for x and y. Okay, so I did that with the 36,221 and the 28, the 500 and the 16, and then you're going to divide piece by piece. This, when you divide 36,221 divided by 500, you get 72.442. When you take a divided by a, it cancels. B to the 28 over b to the 16, you got to subtract. 28 minus 16 is 12. How am I getting rid of that exponent? I'm raising it to the reciprocal. Okay, so 1 over 12, I get b to equal this number. I'm going to take b, plug it into the easier of these 2 looking formulas. I'm going to do the bottom one, looks easier. And I'm going to now solve for a, and there are those steps, okay? Once you have a and b, go ahead and plug it back into the original and leave y and x. And this is now the equation we're going to be working with, okay? You're going to go, for the last part of this directive, now that we have an equation, we're going to create the graph, okay, using Desmos. Okay, so if I go to Desmos, and I'm going to click on the Start Graphing button. Okay, and I will post this link here in the directions. And you're going to go ahead and type in your equation. So I'm typing in y equals, what did I have? Y equals 1.66. And I had 1.429. And then raise to the x, okay? To raise to the x, you're going to hit the little caret button, x. Also down here is different math functions you can do, okay? If you need help with that. Functions, you can do trig, stats, whatever you need help with, you can plug it in. And then there's the graph. Feel free to play around with the different buttons to get a nice looking graph here, okay? and you are then going to put it in your document. You can hit share graph and you can give me a link, you can export the image, print it, whatever you want to do with it, okay? And that's what I did here. Okay, so there's my graph. Feel free to play around, see if you can figure out how to add labels to your axes. I gave the link and the picture if you need help with that. Okay, now we're on directive 3, and this is the kind of the fun part, I'll say. You want to create 2 word problems, and you're going to solve them based on the graph or the equation you just used. Okay, so the first is doing a projected amount. Okay, so you're going to take a future number, so something that's not included in the graph. So if you notice in our graph, we only went up to March 28th. So my question was, what will be the projected amount of cases for March 30th? And I'm using that equation we just got in part 2. For projected amounts, all you're doing is taking this number and plugging it in for x. I'm just taking 30 and plugging it in for x, solving, and notice I round here, okay? Because you can't have 0.7 of a case. This is people we're talking about, so you want to round. If you need help with that, please let us know. The only thing you might need to pay attention to is if your dates go like across like a couple months, you have to pay attention to the start date and how many days after are you looking, okay? Then I do it again for number 2, except now we want a different type of problem where we're solving for x and we got to use logs, especially if you're working with exponentials. And how long will it take for the total cases to reach 500,000? So now I'm plugging in y and solving for x. There's my work base in the basement. Again, reach out if you need some additional assistance. Notice here I get x to equal 35. Well, there's not a 35th day in March. March only goes up to 31, so then April is 32, April 2nd is 33, April 3rd is 34, so it ends up being April 5th. We're here to help you though with that part, okay? So I'm hoping this example really helps you guys out a bit. If you need any more questions, please reach out. We want to see you succeed, and I don't want you to struggle with this, okay? So reach out, and thanks so much for watching.